going to be discussing why e is an irrational number. So, as you might know, there are many possible derivations of the number e. We're going to just use the Taylor expansion of the exponential. So, from calculus 1, we know that e to the x has Taylor expansion about 0, given by the series of x to the n over n factorial, running from 0 to infinity. So to get an expression for e, I need only to plug in x equals 1 into this expression. So I'm going to have this series of 1 over n factorial from n equals 0 to infinity. And now I want to assume, for sake of contradiction, that e is a rational number. So suppose that there is a fraction e over q, where p and q are natural numbers that satisfy this Taylor series expansion. Okay, so the trick comes at this point in the proof. I want to, instead of multiplying both sides by q, I actually want to multiply by q factorial. And we'll see why this is the case in a minute. So I multiply both sides of this expression by q factorial. I'm left with p times q minus 1 factorial on the left side. And on the right-hand side, I can just write this as q factorial over n factorial here. And I can go ahead and split this series up into terms that are going to be fractions, aka when n is greater than q, and terms that, and the earlier terms which are going to be integers, okay? Because q factorial, any previous factorial will divide q factorial if n is less than or equal to q. So for that reason, I can go ahead and split this summation as running from 0 to q of q factorial over n factorial, and then running from q plus 1 to infinity. And since n factorial in this first summand, since n factorial will divide q factorial in each term, we know that this has to be a natural number because we're just adding a bunch of integers together. And similarly, p times q minus 1 factorial is also a natural number, okay? So because both of these two terms are natural numbers, we know that the third term here must also be a natural number. And this is kind of the heart of the contradiction. So we know that therefore the summation of from n equals q plus 1 to infinity of q factorial over n factorial is a natural number. However, we can go ahead and manipulate this expression and show that it's actually smaller than 1, okay? So, and the basic idea comes from showing that each term in this series is going to be less than 1 over 2 to the n, okay? So, so the way that I'm going to do that is I'm going to recognize that q factorial over n factorial, as I move from q plus 1 to infinity, that is going to look like 1 over q plus 1, and then 1 over q plus 1 times q plus 2, etc. And so I might as well write this series as each term being the product of 1 over q plus k, where k runs from 1 to n. And now I can start the series running over n from n equals 1 to infinity here. Okay, so I've basically just rewritten the series to better describe the pattern of like 1 over q plus 1, then I'm adding 1 over q plus 1 times q plus 2, etc. And so I've just recoded that information into a nicer form to work with. And when I do that, I immediately notice that this is a product of fractions that are descending, and each fraction is going to be less than or equal to 1/2. So I can immediately say that this is going to be strictly less than the summation from n equals 1 to infinity of product of 1 over q plus 1 from k equals 1 to n, which is less than or equal to 1 over 2 to the n, okay? Because 1 over q plus 1, since q we already assumed was a natural number, has to be at least 1, and so all of these 1 over q plus 1s have to be at most 1/2, and so we can bound this above by 1 over 2 to the n, where n runs from 1 to infinity, and now this series is just a geometric series that sums to 1, okay? So what we've shown is that ultimately the series that we're left with, this remainder term, has to be less than 1. It can never be a natural number, which is a problem because both of these previous terms, after multiplying by the q factorial, both had to be natural numbers. And so this is the contradiction that tells us that e is in fact irrational. Now, there are very similar proofs for e to the power of n. So I encourage you to try and show, using the ideas of this proof, that e to the power n is irrational. And the hint for that would just be to, again, use the Taylor expansion. And as long as you can get the Taylor expansion in the right form, then it should not be hard to prove that these numbers are irrational. All right, thank you, and thanks for listening, and have a great rest of your day.